Hello, in this video, I'd like to discuss how to show that an argument that's written in symbolic logic is invalid. So let's start with an example. So let's say we have something relatively simple. We have P implies Q, and then we have Q, therefore P. So this is a typically invalid argument. In fact, it actually has a name. It's called asserting the consequence. It's making the error that the converse of a conditional statement is logically equivalent to the original. At any rate, in order to show that this argument is invalid, we must first understand what is a valid argument. So in the previous video, I talked about that an argument is valid if if and only if it is impossible for the premises to be true and the conclusion to be false. So what we could do to show that this argument is invalid is to show that it is possible for the premises to be true while the conclusion is false. An easy way to do that is to, in fact, translate this argument into one in which it is a statement, a compound statement. So what we could do is put all the premises together in the form of a conjunction, and then put large parentheses around the entire set of premises, and make a conditional statement so that the consequence of that conditional statement is the conclusion. So basically, the main idea is this. The idea is that this argument is invalid if and only if its equivalent conditional statement, right, can be shown to be false, okay, or equivalently, we can show that the conditional statement above is not a tautology. Right? So if we can show that this statement over here is not a tautology, then we have shown that, in fact, this argument is invalid, right? Because if it were valid, this statement would be a tautology. So how do we show that this is, in fact, not a tautology? Well, we can do that without even having to create a entire truth table, because all we have to do is show that it is indeed possible for this statement to be false, so this compound statement to be false. So to do that, we're just going to put an F underneath the conditional sign, the if-then sign. Now, to make this false, right, we need the premises to be true and the conclusion to be false, right, or the antecedent of this conditional statement to be true and the consequent to be false. Now, what is the antecedent? Well, it's a conjunction, right? So what we want is we want this to be true. And we want P to be false because that's the consequent of this conditional statement. Now, that's the only way there's going to be F, right? So if we can accomplish this, then we are done. All right, so let's see if we can accomplish this. Now, we did say that P has to be false, so we're going to put an F underneath that P also here. And so now the question is, how do we make this conjunction true? Well, Q would have to, one of the conjuncts has to be true, and therefore I have to put a Q true here also. And the question remains is, will this conditional statement be true? Well, it has to be true, right? It has to be true in order for the conjunction to be true, right? Both conjuncts have to be true. So the one conjunct is Q, the other conjunct is the conditional statement. So as you can see, we were successfully able to assign truth values to P and Q in such a way so that the conjunction here is true and this consequent here is false. So we would say that we have shown that, in fact, this conditional statement is false, and therefore we have shown that the argument is invalid. To make this a little more formal, we want to add here that we have shown that the argument is invalid by demonstrating, by actually assigning truth values to P and Q in such a way that makes the premises true while the conclusion is false. And the assignment in question is precisely that P is going to be false, right? And Q is going to be true, right? So that's the assignment we in fact made, right? If you can see consistently, that's what we did. We made P false and Q true. That's it. That shows that the argument is indeed invalid.